oxygen and reduction in terms of electron transfer. So oxygen is oxygen is loss of electron. So here we can see that magnesium is a metal. Magnesium is being converted into a magnesium ion by sacrificing or by losing 2 electrons. So where are these electrons going? To the chlorine atoms. So why do we have 1 magnesium but 2 chlorine atoms?
A single chlorine atom requires 1 electron to fill its outer shell, while a magnesium atom has 2 electrons to give away.
Exactly. Exactly. So that is the reason. In order to balance the transfer of electrons, the number of electrons moving around has to be equal. Okay? The number of electrons moving around has to be equal. There's no way you release 2 electrons and something else is gaining 6 electrons. It's not going to be possible. If it's possible, that means that the substance which is releasing 2 electrons is actually there 3 times that, or 3 of the same thing. So 3 into 2 is 6 electrons. These 6 electrons are being lost and eventually being gained by its counterpart. So here magnesium, since it's losing electrons, it's undergoing oxidation. Chlorine, on the other hand, since it's gaining electrons, it's undergoing reduction. So this is in terms of oxidation and reduction. This is now, for AS, this is the most important. In terms of oxidation state. So oxidation state is basically the charge of an atom when it's in a combined form or when it's in a compound form. Karon amra jani je when a substance is in element form, when a substance is in its element form, or when it's not combined with anything else, irrespective of the type of compound, it could be an ionic compound, it could be a covalent compound, it could be anything. Irrespective of what type of compound it is, it's always going to have a charge on it. So S2, Na2, S2O8. This is being formed from sodium, sulfur, and oxygen. Okay. So what is the oxidation number of sodium here?
+1.
+1.
Okay, see, মাত্রই আমি বললাম যে whenever a substance is in the uncombined form or whenever it is in its element form, its oxidation number has to be 0. What is the oxidation number of sulfur?
0.
0.
Oxygen.
0.
Sodium normally charge কত হয়?
+1.
1.
Oxygen normally charge কত হয়?
-2.
-2.
-2.
এখানে সালফারেটটা আমাদের বের করতে হবে S2O8 2 minus twice x minus 16 is equals to -2 twice x equals to +14 x equals to +7. So +7. So sodium is changing from 0 to +1. The oxidation number is usually measured or remembered using a number line, where this is 0, this is +1, this is +2, This is +3. This is +4. This is -1. This is -2. This is -3. This is -4. So whenever your change is going to move from the left-hand side to the right-hand side. So eta dekho, it's changing from 0 to +1. So it's from moving from left to right. So whenever it's moving from left to right of the number line, it's always oxidation. Even if the change is from -3 to -1, it's still oxidation. On the other hand, whenever your number line moves from the right-hand side to the left-hand side, it's always reduction. So oxidation number changes from 0 to -2. So it has moved toward left. So if it's moving left, it's always reduction. So these are a few points which shows the difference between valency and oxidation number. So rules for oxidation states. Each atom has an oxidation state. It's represented as Roman numerals. That is the reason we don't write iron 2 chloride. We write it as iron Roman 2 fluoride. So the oxidation number is always represented as an as a Roman numeral. The most important point. Where an element is not combined with other elements, its atoms are in oxidation state 0. You have to remember this. There is no way out. You have to remember this. And therefore, the different oxidation number of the different groups, +1, +2, +3. These are some things you already know. Finding out the oxidation number of a transition element. Hi, Papa. I'm teaching. No, don't disturb. I'll talk to you later. Bye-bye. So potassium chromate or potassium manganate. These are the two most common substances we learned in Redox last year. So both of these act as what type of reagent?
Oxidizing agent.
Oxidizing agent. Very good. So what is an oxidizing agent?
Reduces
It
itself.
oxidizes a substance and gets reduced to itself.
They take electrons.
So now I want to find out the oxidation number of chromate. How do we do so? So potassium is 2 into +1 plus, since there are 2 chromiums, and we do not know chromium, so we take it as X. So it's twice X plus oxygen. Oxygen is, each oxygen has a valency of -2. Although oxygen valencies can also vary. So it's 7 into -2 is equal to 0. So +2 plus twice X minus 14 is equal to 0. Twice X is equal to +12. X is equal to +6. So since this is an oxidizing agent, it is oxidizing its counterpart or somebody else. And in the process, what is happening to itself? What is happening to the oxidizing agent? What is happening to oxidizing agent? It's getting reduced. So আমরা অর্গানিকও পড়েছিলাম যে when we oxidize an alcohol into a carboxylic acid using a oxidizing agent, what is the color change?
Purple to colorless.
Orange to green.
Green.
Orange to green.
So here the chromium ion has oxidation number of +6, and the chromium ion, when it is in oxidation +6, it's going to give you an orange color. And when it turns into chromium 3, it's giving you a green color, because chromium 3 gives you a green color. So here we can learn two things. First of all, transition metals have variable oxidation state. So Nikita, তুমি কি তোমার ওই কোশ্চেনটা আবার একবার রিপিট করবা?
Ji sir. The question was iron 2 sulfate, equation, yes, plus chlorine plus sulfuric acid. তাই না? Adrita and Faizan. Then iron 3 sulfate, Fe2 or sulfate, plus hydrogen, hydrochloric acid.
HDN.
So ওরা iron 2 sulfate বলে দিছে না?
Yes, sir.
Yes, sir.
So let's convert this into an ionic equation.
Sir, আগে balance করতে হতো না?
Balance করা ছিল না, হ্যাঁ।
আচ্ছা, ব্যালেন্স করতে হলে এই যে 2 দিলাম ব্যালেন্সড,
আর HCl আগে
to.
HCl আগে 2. So 2 Fe2 plus 2 SO4 2 minus plus. So we make a mistake যে আমরা একটা কম্পাউন্ডের মধ্যে we add a plus sign, so we shouldn't do it. Plus chlorine we have to write it as Cl2 because it's a non-metal and it's a molecule. Plus H2SO4, again there's 2 hydrogen plus and 1 sulfate 2 minus. It gives us 2 Fe3 plus 3 SO4 2 minus plus 2H plus 2 Cl minus. So what are common here? The sulfates are common. You have 3 sulfates, you have 3 sulfates. You have 2 hydrogen ions, you have 2 hydrogen ions. So basically 2 Fe2 plus reacts with chlorine to give us 2 Fe3 plus 2 Cl minus. So iron is changing from +2 to +3. Again, this is a transition element. Transition elements undergo a jihad. Fe2 plus changes into Fe3 plus. So this is oxidation. And Cl2 changes into 2 Cl minus.
Yes, sir.
0 minus 1. So this is reduction.
Okay.